Okay, I'm going to bring this up and we're going to start this video here for the last section, which is 5-7. Um, it's on what's called binomial expansion. Okay, binomial expansion is I would guess people would consider it a shortcut, although it's not the shortest process either. It's a shortcut for expanding when a binomial is placed to any power. So, for instance, if you had something like x plus 6 to the 7th, okay, if you really wanted to do that, what you would have to do so much foiling because you'd have to write x plus 6 7 times, 4, 5, 6, 7. So you'd have to foil these two together, get an answer, foil it with this, get an answer, then foil that with this, get an answer, then foil that with it, and so on and so on. Okay. So this is a little bit shorter way than that, and it's also just kind of a crazy happening and finding um, that a guy whose last name was Pascal find. Okay, so Pascal's triangle Pascal's triangle is what we're going to use to begin our shortcut. You don't need to memorize Pascal's triangle. You do need to memorize how to form it, though. Okay? It's very easy. It's formed using a pattern. What you want to do is start with a 1 on top. And every row is going to have one more number in it, but ones are always going to be on the outside. So this one just has a single 1. Next, we put a 1 on each side of that. The next row is going to have 3 terms, but we put ones on the outsides, and then we add these numbers together to get the number 2 in the middle. Again, ones on the outsides, and now add your pairs of ones together to get the numbers to fill in the rest. Ones on the outsides, add, add, add. Ones on the outsides, add, 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 add. I'm going to do one more row. I think you are starting to hopefully catch on. Ones on the outsides, add. Okay. Now, the most important thing to remember about Pascal's triangle is at the very top, they call this row 0, which means that this is row 1, and this is row 2, and this is row 3, row 4, row 5, and row 6. How I remember that is that the row number is always the number that's right inside the 1. So right inside the 1, this is row 2. Right inside the 1, this is row 3. Right inside the 1, this is row 4. Right inside the 1, this is row 5. Okay? And so we're going to use Pascal's triangle to be able to do what's called binomial expansion. So let's say that what we wanted to do actually was to do 3x minus 2 to the 5th power. Okay? Here's how binomial expansion works. Whatever your exponent is, you want to go to that row. So I'm going to work with row 5 because my exponent is a 5. Okay? Now, the numbers in row 5 are my coefficients. Okay? I do need to identify A and B. Okay, so A here is 3x, and B here is negative 2. Okay, so to do this, I go to row 5 because that's my exponent. Here's my first number in row 5, a 1. I will start by taking A, which is 3x, and putting it to the exponent that is listed here in the row that I'm using 5. And the B, which is negative 2, will go to the 0 power. So you always start with the A going to the exponent that you're given, and the B going to the 0 power. Okay? Now I add that to the next number in the row that I'm using, 5. This time A is to 1 less power, the fourth, and B is to 1 more power, the first. Plus, next number in Pascal's triangle, 10. This time, again, A is to 1 less power, the third, and B is to 1 more power squared. Plus, next number in Pascal's triangle, the row 5, is another 10. This time, again, A, 1 less power squared, B, 1 more power to the third. Next number in the row, a 5. A, which is 3x to 1 less power, 1, B to 1 more power, 4. And finally, the last number in the row, 1. This time A is to the 1 less power, which in this case is 0, and B is to the 1 more power, 5. Notice how my exponents always add to be 5. 5 and 0, 4 and 1, 3 and 2, 2 and 3. They will always add to be whatever your original exponent was. Now, I just need to do all this math. Here's things to remember. Whenever you put something to an exponent in your calculator, you need to put it in parentheses, or you'll get every single one that's a negative wrong. Also, remember that anything to the 0 power is 1. Okay? So, the first thing I'm going to do here is I've got all this math. I've got 1 times 3x to the 5th. What is 3 to the 5th? Let's figure that out. 3 to the 5th is 243. So I got to give this fifth to the 3 and the x. So at 1 times 3 to the 5th is 243 x to the 5th times negative 2 to the 0. Anything to the 0 is 1. Plus, I've got my 5 times 3 to the 4th is 81. So this is 81 x to the 4th times negative 2 to the 1st is negative 2. Plus, I've got 10. 3x to the 3rd. 3 to the 3rd is times 27 x to the 3rd times negative 2 squared is positive 4. Plus 10 times 3x squared. That's times 9x squared times negative 2 to the 3rd is negative 8. You could use your calculator if you need to. Plus 5. 3x to the 1st is just 3x times negative 2 to the 4th is 16. Plus 1 times anything, 3x, but anything to the 0 is 1 times negative 2 to the 5th is negative 32. And now I just do this math. So 1 times 243 x to the 5th times 1 is just 243 x to the 5th. Here I've got 5. I'm bringing my calculator back up here. I've got 5 times 81 times negative 2. 5 times 81 times negative 2 is negative 810. And I have these x to the 4ths. In this term here, I've got 10 times 27 times 4, which is plus 1080 x to the thirds. In this term here, I've got 10 times 9 times negative 8, which is minus 720, and they are x squareds. Here I've got 5 times 3 times 16, which is plus 240, those are x's. 1 times negative 32 is minus 32, and that's done. Let's do one more just to see if it will help you catch on here. Let's say that I have, well, I'm going to leave Pascal's triangle up there so you can reference it if you need to. Let's say that this time I want to do 2x plus 4 to the 4th. That means this time I'm going to be using row 4 of Pascal's triangle. A, of course, is 2x. B is positive 4. So, first number in row 4 of Pascal's triangle is a 1. I put the a, 2x, to the exponent that's given, 4, times b, which is 4, to the 0, plus. Next number in the row is a 4. This time a is to 1 less power, the third, and b is to 1 more power, the first, plus. Next number in the row, 6. A is now to 1 less power, squared. B is now to 1 more power, which is also squared, plus. Next number in the row, 4. A is to 1 less power, the first. B is to 1 more power, the third, plus. Last number in the row, 1. This time A is to the 0 power, 1 less than 1 is 0, and B is to the 1 more power, fourth. Now, here comes my math. I've got 1 times 2 to the 4th. 2 times 2 is 4, times 2 again is 8, times 2 again is, that's 16x to the 4th, times 4 to the 0 is just 1, plus 4 times 2x to the 3rd. 2 to the 3rd is 8x to the 3rd, times 4 to the 1 is 4, plus 6, 2x squared, that's times 4x squared, times 4 squared is 16, plus 4 times 2x to the first is just 2x, times 4 to the third is 64, plus 1 times anything to the 0 is 1, times 4 to the fourth is 256. So 1 times 16x to the fourth times 1 is just 16x to the fourth, plus 4 times 8 times 4 is 128x to the third. 6 times 4 times 16 is plus 384x squared. 4 times 2 times 64 is plus 512x plus 1 times 1 times 256 is 256. I'm sure you'll have questions. You can ask them tomorrow.